So question 4 says Haraya owns two triangular plots of land, ABC and ACD. The length of AB is 30 meters, BC is 50 meters, and AC is 70 meters. The size of angle DAC is 55 degrees, and angle ADC is 72 degrees. Haraya attaches a 20 meter long rope to a vertical pole at point B. So what we're looking for here in part A is the length of AD. And our strategy is going to be, we're going to find this angle up here. I'm going to call it alpha. And we're going to use that angle to find the side that we ultimately want, that I'll call side X. So the first tool we're going to use is triangle angle sum, and the second tool we'll use is the law of sines. We know from triangle angle sum that all the angles in a triangle need to add up to 180 degrees. So if I take that total 180 degrees and subtract from it the 72 degrees and subtract again the 55 degrees, that will give me my angle alpha. So we know that alpha is 53 degrees. From there we can use the law of sines because we have one complete side angle pair and one halfway complete side angle pair that involves the side we're looking for. So the law of sines allows us to set up the proportion x over sine of 53 degrees is equal to 70 over the sine of 72 degrees. So if we can solve this, then we can solve for x. And so we will cross multiply here to get that x sine of 72 is equal to 70 sine of 53. And so if we divide both sides by the sine of 72 to get x by itself, we get, after plugging in the right side into a calculator, that x is equal to 58.9 centimeters. So there's our first answer for part A. Part B says find the size of angle ABC. So that is this angle out here in the corner. Notice that triangle ABC is not a right triangle, so we're going to have to use the law of sines again, or the law of cosines, to find parts of this triangle. In this case, we're going to use the law of cosines because we have three sides. We know the 50, we know the 30, we know the 70, and we're just looking for a missing angle. So the law of cosines has the formula c squared is equal to a squared plus b squared minus 2ab cosine c. In this particular case, we are going to call the 70 little side c, and the angle that we're looking for is big C. We know this because this is the side angle pair that we're working with. Then it doesn't matter at this point which side you let be A or B. That 50 and the 30 are interchangeable at this point. So in the formula I have 70 squared is equal to 50 squared plus 30 squared minus 2 times 50 times 30 times the cosine of C once we plug in our sides. So simplifying this, 70 squared is 4,900, 50 squared plus 30 squared is 3,400, and then negative 2 times 50 times 30 is negative 3,000 cosine of C. A really common mistake here that I want to make sure you all don't make is to take the 3,400 and subtract the 3,000 from it. We cannot do this because that would be breaking order of operations. there's a multiplication happening here between the negative 3,000 and the cosine. So that multiplication would technically have to happen before we can do the subtraction. Because we can't multiply at this point because it's an unknown, we're going to subtract the 3,400 from both sides to get 1,500 is equal to negative 3,000 cosine of c. And then we will divide both sides by negative 3,000. So over here what we get is negative a half is equal to cosine of c once you simplify the fraction 1,500 over negative 3,000. So to get c by itself, our last step is to apply the inverse of cosine, which is cosine inverse, to both sides. And plugging in the left side into the calculator, we get that c is equal to 120 degrees. Part C says calculate the area of the triangular plot of land A, B, C. So we know that we have all the sides of triangle ABC, and we just found from part B that this angle right here is 120 degrees. So we can use the formula A is equal to 1/2 AB sine C. Because in order to use this formula, we just need two sides and the angle between them, which we have with that 50 and the 30 with the angle 120 between them. So plugging that in, again, it doesn't matter which side you call A and which side you call B, because with multiplication, the order doesn't matter. That's what our formula looks like after we plug in all those numbers. And then into the calculator we go, and it gives us 649.519058, oops, not centimeters, meters squared, or rounded to three significant figures, that gets us 650 meters squared. Lastly, part D says determine whether the rope can extend into the triangular plot of land ACD and justify your answer. So let me clear off the picture once more. We have a rope that is 20 meters long, and what that tells us is for the part of the circle that they've drawn for us, the radius of the circle is 20 meters. So the question is, if we keep swinging this rope around, once it gets into the little triangle, is it going to cross that line AC anywhere over here? That's what this question is asking. So the shortest distance from point B to the line AC is this one that I'm drawing in orange. It's actually a perpendicular line that passes through B. So this right here is a right angle. That orange line segment happens to also be the height of the triangle, which is a really key observation. So we can find the height of the triangle. If we can, then we'll be able to see if the rope is long enough to get from point B to the line CA. We're going to use the other area of a triangle formula to do that, because that formula has the height of the triangle in it. So the second area of a triangle formula is 1/2 times base times the height. So the height is the thing that we don't know. That's what we're looking for. But we do know in this case, if that's the height, then our base is that long side, the 70. So for B, I can plug in 70, leave H as is. That's what we're solving for. And actually from part C, we know that the area of this triangle is 650 meters. And so this gives us a pretty simple formula to solve. 1/2 of 70 is 35. So on the right, we've got 35H is equal to 650. If we divide both sides by 35, what we find is H is equal to 18.6 meters. So because that 18.6 is less than 20, which is the height of the rope, then we can say yes, the rope can extend into ACD because the rope is longer than the height of triangle ABC. And we are done.